I could start attracting crowds. The fat cat on the mat may seem to dream of nice mice that suffice for him or cream, but he free maybe walks in thought, unbowed proud by the Lord, loud and fought. His kin lean and slim and deep and in the east feasted on beast and tender men. Anybody know who wrote that poem? I will guarantee everybody in the room has probably read something by this author. Don't worry, no one ever gets this. It was written by J. Tolkien, who actually wrote a tremendous amount of poetry. And this was one that he literally saw his cat sleeping in front of a fireplace and decided to write this poem in honor of his cat. His cat apparently weighed 31 pounds. The fat cat piece was apparently really honest. We've got a couple more minutes before we get started. I just wanted to make sure the microphone was working. Okay, anytime? Cool. Hi there, I'm Dave McAllister. I work for a little company project, actually, you may have heard of, called Nginx. Nginx is owned by a bigger company called F5, but we're pretty much left alone. Not totally, but we are pretty much based in that. We started as an open source project. It was first announced in 2002, became an open source 1.0 product in 2011 when the company was formed, and then F5 acquired us in 2017. So moving that. The good news is I'm not talking about any of that. And this is going to be one of these talks that hopefully you'll get something out of, but it may not apply to configuration controls or OpenTelemetry displays and so forth. But it's something that's just fun. And part of that is driven by this talk that I was allowed to do last year called The Stats Behind the Alerts. I'm not sure if anybody, now that this light's in my eyes, not sure if anybody's actually saw that talk, but it basically covered what kind of statistics do we deal with when we're looking at the alert structures. What are the machines actually telling us? This one is different. There's a lot of capability to use data in inappropriate ways. And the first place, lies, damn lies, and statistics. This is quite often a common phrase and was most often related and said by Benjamin Disraeli. There is no proof that Benjamin Disraeli ever said this. The only place that this was ever said was in the autobiography of Mark Twain, who says along the lines of, figures often beguile me, particularly when I have the arranging of them myself, in which case the remark attributed to Disraeli would often apply with voice and justice. There are three kinds of lies: lies, damn lies, and statistics. Statistics not only gets used to lie, but the references to the people making the comments also gets used to lie. So statistics is a data-driven model. This is a data-driven world. We've heard more talks about getting data, moving data, understanding the data that are going on here. And it lets us do evidence-based decision basis. It lets us set realistic and measure realistic goals. It's got a cultural impact, the way that we look at things in here. It lets us manage risk. But we have to consider that source of data, including the methods about how it's collected, how it's analyzed, how it's presented, as well as questioning some assumptions. And that's where we're going to go for this. This is a numbers game. It is definitely a game. And we have misinterpretation. We have the ability to pick the data that was most interested to us. We can visualize. Visualization is an incredibly powerful way to lie. We'll look at a couple of examples of that. And then we have biases, not only survivorship bias, but we'll go into selection bias and those pieces. Generally speaking, what happens, and I'll try not to get too much into it, in advertising and politics is that people fit the reality to the statistics that they are interested in. And last year, I asked the question, do you know what a mean, a median, and a mode is? And the answers come down to about 85% of the people feel like they knew what a mean was, about 50% felt they knew what a median was, and about 10% felt like they knew what a mode was. Interesting set of numbers. And by the way, I just lied with statistics. People will assume that you were telling the truth if you put a number with it. And if I had come back and said 84.9%, you actually have more trust in that series of numbers. Saying what you mean. The current average income of the U.S., I didn't have time to change all these things, is $59,000 and change. The average household size in the U.S. is 2.63 people. So obviously, the income per household as $156,179.22 US dollars. It's not. It's actually $106,400. There's obviously an interesting area here. Using the same way, if you want to earn $1 million, you just need to have 14.8 kids, right? So if you multiply it out, that's what happens. The problem is that the number of people in an household do not all earn money. The household itself is broken down into different pieces. But this is an interesting way of lying with statistics and being able to prove it. This first showed up in 1957. This concept showed up in 1957 with two magazines that were trying to make themselves look bigger and better. And they were doing these weird comparisons around how much the average person earned. Your downtime target is 1 hour per month trailing. Would you rather report 1.5 hours or 0.53 hours? If your target is 1 hour, you'd much rather report 0.53 hours. The first one is the arithmetic mean. The second one is the geometric mean. Big difference between those two here. And when you start looking at that, you can't necessarily trust what the mean is going to tell you. And that's partially because we have this thing called this deviation stretch. The range matters. And I love this point. A single point, if I look at you and say, the arithmetic average is 17, it is meaningless. You now have a number. Is it 17 out of a range of 10,000 or 17 out of a range of 3 items? You don't know. It doesn't tell you anything. The mean temperature in Death Valley in the U.S., you can see what it says there, is 61 degrees or 16.1 Celsius. In the Death Valley, that is the average for a year of the temperature, but the range is from 15 degrees to 104 degrees. Okay, that's a big difference. Everybody would be very comfortable with that 16 degree number, but you get pretty cold when it goes below zero, and you'll get pretty hot when it hits 40. Keep in mind that distribution without expressing deviation is worthless. Similarly, looking at a collection of response times from a server, sample A looks pretty good, sample B is a little bit more thing here. Sample A's deviation is 3.3, sample B's is 44.8. Their means are exactly the same. Keep in mind that your range does matter. And this also leads to the size of your collection. I played around with this thing called the paranormal distribution on this. If you sample an individual, your range can be over a very wide target. As you add more data to that structure, your range of capabilities gets narrower. So the time can be very broad in terms of its deviation allowance, but it can also be very narrow. It depends on how much people are looking at that particular data. And that leads us to this secondary thing that says, you can really lie with sampling. Steve and I used to work at Splunk, and I used to get really irked at sampling and what people would do between head sampling and tail sampling and observability, and there are conclusions they would draw for this. The results are only good as your data. It can be really convincing, but size matters. I'm gonna try to see here. How many people in here had tea for morning in the morning? Okay, 1, 2, 3. Okay, so if I sampled those two people, I could say 100% of the attendees at SREday drink tea. You don't know. It would not be a conclusive sample, but it's still a sample for that. I can pick 4 people. I could literally have gone down the row and asked people until I get the sample size and responses I want. If they don't tell you this, it's really important. In sampling, bias is the challenge. If you don't see the bias in a sample question, look harder. It's biased. And when you start doing that, you also got to look at that selections and things like that. Similarly to that, you can break a sample and show any conclusion you want, again, by using the data. This is the standard XKCD slide. Yesterday, you got married. Today, she now has a husband. fast forward out, obviously extrapolation is going to give you that you better buy cakes, a lot of wedding cakes, okay? Extrapolation is useless. It is not a safe structure. Interpolation may be safe. It's a little bit risky, but extrapolation, the farther out you go, the more risk you have. Think of it this way. If you haven't had any outages recently, your mind says you don't have any outages. We tend to believe things are going to continue as they always are. It's a simple way of lying inside of here. You can prove your predictions just by making your predictions post-functionality. Bias deserves coverage in its own right for this. First one is self-selection bias. You're trialing a new deployment tool. You've invited the senior engineers to try the new tool. You've now fallen into selection bias. You have chosen a subset of group of people for something that will affect a larger group of people. And your grouping a selection is not random. It's actually very focused inside of here. And when you do that and you start querying these people, you can now fall into confirmation bias. Confirmation bias personally drives me up the freaking wall. Sorry, language for here. But it's how to phrase a question so that you get the answer you want, or you can interpret the answer you want. Everybody's gone through, since we had the wonderful pandemic, we went through the work at home, return to offices, hybrid work, and so forth. So imagine a question that says to a large company of people says, do you understand the return to office policy? And HR has gone through, talked about it, it's been published, emails, etc. And 86% of the people come back and go, yes, I understand the policy. And then it gets interpreted, look, everybody agrees with the policy. 86% of the people will agree with the policy because they understand it. Those are not related. And so that's a confirmational bias structure that's really nasty. I spend about a third of my time picking apart surveys that get sent to me for a confirmation bias, and I can always find it. Every single time I can find a confirmation bias. Okay. Recency bias. We talked a little bit about this. We expected things to stay the same, but a recency bias is only going to try to ask you about the last thing or the most recent thing that has happened. So, quote, these people have used this. How much did it help you in your last deployment versus did it make a difference in your deployment? Think of it this way. People look at only the last thing. And you can actually have recency bias go either way, because that leads us into the status quo bias. The status quo says, way you ask the question leads the answer. Quote, how disruptive was the new tool? How much did it change you? And you'll get negative responses. Versus how much did it improve? And you'll get positive responses. The status quo bias says change is scary, and because of that, people don't like to change. It's just built into us. We don't like lots of changes. We are always going to be resistant until we get used to the change. In surveys, status quo bias is used to get the result you want. That leads us into visualization. So this is actually and is an approval rating chart. Anybody notice anything missing? Anything on an axis anywhere? Okay. Chart looks really good. Man, God, look how much you've improved your approval rating here. Misleading visual representations are everywhere. I will guarantee that if you open a magazine, a newspaper, or a website that has a chart, there's probably something misleading. Not always, but generally speaking. First of all, we don't have any data. We don't know what the changes were. We don't even know how long it took over this period of time. Oh my God, let's correct that. So this one now has an axis over here, 100% to 0%. What's this thing? You don't usually get to see this little line. You just usually get to see a bar. That's there. And these are called graph cutouts. Graph cutouts don't tell you how much is missing in the graph. This is exactly the same line, but we don't know how much has been taken out of the picture. Again, now it looks even more realistic, but with less data. Okay, so look, oh gosh, okay. No cutouts, the numbers go from 1 to 100. The line really flattened out a lot. but it looks really high. So there must be a high approval rate going on here. Okay, this is another tricky little one here. This is actually a logarithmic chart. When we look at the real chart, that's what it looks like. The chart's about 37% approval rate, and the number, by the way, went from 33 to 38.1 over the course of 14 months. Not a tremendous amount of improvement over a fairly long period of time, but my God, picking the right visualization makes all the difference. Similarly, you can do it not just with graphs, but you can actually do leading the witness models. Leading the witness model says, pick the one you want to have people pay the most attention to and make it bigger. Okay, this went from a 1 doubled, quadrupled, except at the same point in time, I did the bars. It's 1 to 4 to 16, not 1 to 2 to 4. People will immediately look and go, this must be a really good one because look how big it is. And people will ignore all of the other pieces that are inside that. And to make it even more compelling, you can do exactly the same thing with cutesy pictures. This is called the one-dimensional picture approach, where you use a really big picture to show off. And by the way, just in case you didn't notice it, notice this little chart here, how much gaps there are between those things. There's nothing that says I have to present a graph that is 100% linear if you don't catch me. Okay, now we get into how to lie with percentages. This one's always lots of fun. This one is data from 2008, I think. Yeah, 2008 data on gaming systems. And the article came out and said, oh my God, look how poorly the Wii systems are doing. Wii systems are way down here. Only about 6% of people ever use them. All those different things. And look how great the Xbox 360 is doing. Okay. What they didn't tell you is there are 50 million Wii owners. That number is 3 million, 6% of it. There are 30 million 360 owners. That's 3.3 million in terms of the percentages there. There are 20 million PS3 owners. 10% of that number is 2 million. If you actually broke this down to where they are related numbers, there's not a lot of difference inside of there. But it looks really great on this graph because, my God, look how low that number is. More people were using this than is being represented in the graph. The one over here, there's a rule of thumb. Actually, there's a statistical thing that says pie charts should add up to 100%. This one adds up to what? 145, 10%. Okay. And by the way, the three things aren't leading. This would be better if it was done as a bar graph showing no relationship. But the pie chart makes you feel like it's related between them. And even though the subjects are related, they have no conclusion between them. Okay. There are lots of other ways of lying visually. These are the ones that you see most often. So let's go into the if B follows A causes B. And this is the standard. You want to prove you've got too much automation. Your DevOps teams notice that as the number of automations have increased, so have the number of incidents in production increased. Therefore, automation is causing problems in production. No, you don't know. Okay, maybe the problems in production are creating more opportunities for people to automate. You really don't know inside of here. And correlation is not causation, even though you have to be careful. Because sometimes it is for here. Summer time frame, ice cream sales go up, that's correlation. Summertime, sun comes out, you get a sunburn, that's causation for those. And you can have all sorts of weird things that happen within the time frame. This is my favorite sneaky correlation. There is almost a perfect correlation between marriage and the sales of beer. 99, the R factor is 0.99, which is about as perfect as you can get. There's no such thing as getting a 1. The R squared coefficient of relationship is 0.99 being the perfect set as well inside of here. Does marriage cause drinking? Or does drinking cause marriage? Okay? Neither. This is a confounding factor. Okay? Population growth made both of those numbers grow at the same rate because the population was exactly the same growth rate. I could have done the same thing by showing car sales. I could have done the same thing by showing the amount of property being bought because the correlating confounding factor is common. A and C are not related. By the way, speaking of the averages category, more people in the history of humankind have died than are alive. On average, all of you are dead. Leading to that same thing, you can do this thing called find whatever you want to say. And this brings us into data dredging and p-hacking. And data dredging is looking at large data and finding out what you want. P-hacking is manipulating the data analysis process. This is a fun one. This is data dredging. This graph came out. Did I put in a reference? I try not to necessarily always refer these things. Ben and Weller actually pulled this chart together. This was in a very famous newspaper. And it said, look at what happened. Why are people worried about global warming? Over this period of time, global warming didn't move. Yeah, it got cold, it got hot, it got cold, it got hot, but it's all exactly the same. This was picked from a much larger chart that looks like this. And they picked very carefully a range of things to show what their intention was. If you look at the overall chart, you can see that there are changes that are inside of that. I promised not to talk about too much about politics. I have to, because this one was just too sweet to do. U.S. politician, March 2nd, 82% of the country realizes that 2020 was a rigged election. And I went, huh? Okay, it makes no sense. So I went and dug the data sources out. And the data sources, this is called post hoc or ergo propter hoc, after this, therefore because of this. The source was Public Religion Research Institute. I think I feel a selection bias coming on here. By the way, they actually did a really good job in their data. But one of the questions over here, you can see, belief that the presidential was stolen by the trusted news source. And down here, you can go through and see All Americans, etc. There's this thing called Most Trust Fox News. Most Trust Fox News is 47 plus 35. Imagine that, 82%. If you trusted Fox News, you believe that the election is stolen. That title had no concept of that. But if you look at the numbers, most trusting Fox News was about 66. It's either 66 or 67, I couldn't figure. Which means that 82% is 54, or 54 out of this 2,500 number is 2%. Absolutely, totally accurate data misrepresented as a headline. Very simple to do. This is called how to dredge the data to get the results you want. And of course, that leads us to the fact that we do have the ultimate question of life, the universe, and everything, which if the end of the book was, what do you get if you multiply 6 times 9? And that is completely correct. The number is 42, base 13. So always look at what it's trying to tell you. Statistics are informative, enlightening, and they're actually pretty cool. I've actually had more fun dealing with these things here, but it's up to you to understand whether it makes sense or not. Always look for the bias. It's going to be there even if the person who wrote the samples doesn't realize it. They're always going to be biased here. There are confounding variables. People will use A and C together when B is actually the connecting factor here. There are always going to be pretty pictures. Always look for the bias. Always look at the pretty pictures and make sure it's got the data that's there, and always try to figure out how many people are going to take advantage of this. 4 out of 5 doctors in the 1950s smoked Camels by going to a conference and handing the doctors as they left a carton of Camels and asking them that. Statistics are history. History is written by the winners. When somebody represents something data-wise to you, make sure that you understand what part of history they are rewriting. With that, I'll set these slides out. There's a whole bunch of selected readings here. How to Lie with Statistics, written in the 1950s, is the ultimate guide. You will laugh your way through the entire document for that. And again, Nginx, open source, all those different pieces inside of here. And with that, thanks, and I'll open for questions. Which one? Oops, right, that one.
Questions?
There's 2 buttons. There's too many for me. There was actually questions. Oh my God. I will admit, during the stats talk last year, the first questions I'd ever gotten in 13 attempts to do that stats talk were here at SREday.
Thanks for talk. With all these kind of modern tools do lots of data aggregation today, like Prometheus. I find a lot of people end up misusing and abusing the queries, and there's a lot of complexity behind the scenes and how the numbers that Prometheus spits out get created, and lots of people jump to conclusions about what they mean, especially when talking about SLOs, which we use a lot in SREs. Do you have any advice on how to get people to, I don't know, use these aggregations in a better way, or at least help people stop and think?
Yeah, actually, that's a really interesting question, is how do you get people to recognize their own bias, very honestly? And generally speaking, it's really hard to do that. We as humans tend to look for patterns that we recognize and look for patterns that we want. So the only way I've actually been able to get this change, for instance, with confirmation bias, is constantly going in and saying, hey, look at what this is actually trying to say. And doing it with graphs, looking at the data. My world is GitHub. I look at a lot of chaos metrics, and I get people to drill a lot of chaos metrics. It makes a really big difference when I look at this and say, this is what you picked, and this is what the big picture looks like. But it takes a long amount of time to change people's behavior and mindsets. Sorry, no easy answers for that one.
Thanks.
All right. One more?
There's one right there.
In general, you could say that any statistics, any observation that's done is flawed in some way, right? It's somewhat biased.
Any sample survey
Right.
has a bias.
How do you know in practice how long to look for bias? Or how do you figure out how much time you actually can spend on trying to find out, like, where is the flaw in that?
So part of that is a lot of practice. But generally speaking, read a question, any question, or read the numbers and the choices that are being made, and ask yourself how you would ask the question differently. That is the easiest way to spot bias. Because if you read the question and reword it for yourself, that means you understand what the intent of the question was, and you will discover bias that way almost every single time. It's the easiest way.
Thank you.
Sure. Thanks for having me. Thanks for allowing me to come back and talk about my weird subjects to Conf42 and SREday, and have a great rest of the conference.
Thank you, Dave.